All right, you guys, so what you're going to be doing is you're going to be going ahead and writing the terms of the sequences given these equations. Now, sequences are different than regular functions because they only include the whole number terms, whereas functions include all values of x, or in this case now we use n. So what we're going to do is we are going to go ahead and we're going to list it as a of 1, a of 2, a of 3, a of 4, a of 5, and a of 6. So first problem we're doing a of 1, a of 2, a of 3, a of 4, a of 5, a of 6. Now if you show your work, that is recommended. So the first thing you're going to do is 2 times 1 plus 5. That's 2 plus 5, which is 7. So that first term is 7. Then 2 times 2 plus 5, that's 4 plus 5, that is 9. Now, if you look at your equation, if you remember back to linear functions, that slope is telling you what you're increasing by each time. So looking at that pattern, I've got 7, then 9. This is going to be 11, 13, 15, and 17. So please show your work on the first couple, and then from there you can use that pattern. Now that only works for linear, or in this case we call it arithmetic. If you think, if I can spell, if you think back to, elementary school, when they talked about arithmetic, that's spelled the same way, pronounced differently, but arithmetic literally means adding. Therefore, you are adding 2 to each output that you were looking at. It's growing by 2. That's kind of how you would graph a regular line. Now, B is different because it is not arithmetic. If you look at it, that is in the form of an exponential. So this one is going to take a tad more work. We are going to need to write out, what are we looking at? We're looking at f of n. So we're saying f of 1, f of 2, f of 3, f of 4, f of 5, and f of 6. So that's going to tell us what we're plugging in for each one. So if we take a peek, parentheses are extremely important. So this is -3 of the 1 minus 1 power. 1 minus 1 is 0. -3 to the 0 power is 1. Anything to the 0 power is 1, so do not forget that nice little property. Now we have -3 to the 2 minus 1. So 2 minus 1 is 1, so -3 to the first power is -3. Now we are going to plug in a 3 minus 1. So that's -3 squared. That turns to a positive 9. Now, if you can look at the pattern on this one, what would be the pattern between here and here? Hopefully to yourself, you say you're multiplying by a -3. And we're multiplying by a -3 on this one. So what we can do now is 9 times -3 is -27. -27 times -3 is a positive 81. And then 81 times -3 is -243. I doubted myself on that, but I am right. So hopefully you can see the pattern. If you remember with exponentials, say you had 2 to the x, you'd be multiplying your outputs by 2 each time, and if you look, that's what we're doing. This format is not linear or arithmetic. We call this geometric. That means you are multiplying those outputs. All right, hopefully that makes sense. We'll get into some more examples of some more detailed sequences.